opposite over hypotenuse. That cos theta is equals to adjacent over hypotenuse. This is very important. And then tan theta is equals to opposite over adjacent. This you must remember whenever you approach this question. If it's not given in this form, it can be in a diagram form. We can have a diagram, and then there we have coordinates 2 and 5. Opposite, okay, here it's opposite according to definitions. In your numerator you have opposite, and then here you have your adjacent. So if the information is given like this, you need to identify which sides are given according to the definitions. So we know that 10 is opposite over adjacent. So if we are given 10 theta equals to 2 over 5, it will mean that 2 is for opposite and then 5 is for adjacent. All right. Now, if it's given in a diagram, not in this form, you will have coordinates. Your coordinates will be here 5 and 2. So in this question, you can be given the information either in this form or in this form. Now, how do you find sine theta now? When you look at the definition of sine theta, it says opposite over hypotenuse. And the information given here, it's opposite over adjacent. Meaning that you need to calculate what your hypotenuse is. Because for sine theta, you need hypotenuse. Now, to calculate the missing side, you use theorem of Pythagoras. Remember, theorem of Pythagoras is opposite squared plus adjacent squared equals to hypotenuse squared. So opposite, there it's given as 2. So you'll have your 2 squared plus adjacent is given as 5. Plus 5 squared equals to your hypotenuse squared. As you solve, 2 squared is 4. 5 squared is 25. Hyp squared. So 4 plus 25 is 29. Then you have hyp squared. To get rid of a square, you introduce the square root sign. Then it will mean that your hypotenuse is square root of 29. So when the third side comes to solving problems on a diagram, this is what you do. Remember, when the other side is not given, use theorem of Pythagoras, and then you substitute using your definitions. Now, on the very same question, if we have to calculate or determine the cot squared theta plus 1, still you must remember your definitions. For cot, remember, cot is reciprocal of 10. So 10 is opposite over adjacent. That will mean your cot will be adjacent over opposite. So adjacent there on the information given to us as 5 over opposite is 2. You must square it. You must square it when it's given as square, then plus 1. Then you make use of a calculator from here. 5 squared is 25. And then 2 squared is 4 plus 1. You can add the 2 in your calculator, insert it as it is, and then write your answer. That is using the definitions when the question is based on diagram. Right. Still on question 3, we can have now the equation. The trig equation. Equation we are referring to an equation like this. Cos theta equals to 0,5. Or maybe cos theta equals to half. Then next to it, there will be a restriction. Remember, if there's a restriction here, it is guiding you whether you consider all 4 quadrants or only 2 quadrants or only 1. Suppose this one we have theta less than 270 degrees, theta less than 270 degrees, greater than 0 degrees. So you can see that if it says less than 270 degrees, greater than 0 degrees, when we solve for our solution, we are not going to consider the 4th quadrant. Remember, from here in our quadrants, from here to here, it's 90 degrees, and then we have 180 degrees, then 270 degrees. Then it means when it's like this, when you do your solution, you don't consider the 4th quadrant. So this is how you approach this question. If we are solving for theta, this can be x, it can be alpha, but remember this is representing an angle. So if you are solving for an angle in your calculator, you will press shift cos. And then when you press shift cos, this will appear, the arc cos. And then this side you'll be left with theta. Then you'll have arc cos of 0,5. Then after pressing shift cos, insert 0,5 so that we have cos of half. And then the calculator will give you an answer, and that answer, it's what we call the reference angle. Now, once you have this reference angle here, you will now have to check this 0,5 as positive. You must now go to your Cartesian plane and identify a quadrant where your cos is positive. Cos is positive in the 1st quadrant and the 4th quadrant. Remember the cast rule. In the 1st quadrant, they are all positive. 2nd quadrant, it's only sine and it's reciprocal, cosec, of course. In the 3rd quadrant, it's tan and cot, which are positive. 4th quadrant, it's cos and sec. Now, the restriction excluded the 4th quadrant. That means we will only consider the 1st quadrant. So if you consider the 1st quadrant, it means your theta solution for your 1st quadrant, your theta will be equals to this answer that you got here. The answer from your calculator. But if this was theta less than 360 greater than 0 degrees, including with this one included, then it will mean we will have to say 4th quadrant. In the 4th quadrant, we know that in the 4th quadrant we have 360 degrees minus. So this will be theta equals to 360 degrees minus this reference angle that you calculated here. That is from your calculator. You will say 360 degrees minus the reference angle. Then it will give you this solution. That's if the restriction did not say 270. We have 360 degrees here. All right, that is the equation. Moving on, in our question 3, still on trigonometry, the other thing that we have is identities and reduction. Learners, there are a lot of marks on this question. So you need to make sure that you grab all the marks. When you deal with this question, you need to remember the following. The identities. We have quotient identity where we have 10. Theta equals to sine theta over cos theta. This is very important. That means when we deal with this question of reduction and identities, we need to remember where we see 10, we have to write sine over cos. The other identities that you need to remember is that when you see sec theta, you should write it as 1 over cos theta. When you see cosec theta, this is 1 over sine theta. And then your chord, theta, it's 1/10. But when you deal with identities, since chord, it's the reciprocal of 10. For chord, where we see chord, always write cos theta over sine theta. Now, let me make an example. Because in your formula sheet, you also have the square identities, which are at the bottom of your formula sheet. Let me show you before I get to the example. Sine squared plus cos squared equals to 1. There we have it. This is also important when you deal with this question. Sine squared theta plus cos squared theta equals to 1. That will mean where you see sine squared plus cos squared theta, you write 1. 1 plus tan squared equals to sec squared. In other words, when you see sec squared, we write 1 plus tan squared. Where we see 1 plus tan squared, we can write sec squared. And then the third one, it's cot squared theta plus 1 equals to cosec squared theta. These are the square identities. So you need to remember them when you solve identities and reduction. Here is an example of reduction. Sine squared pi plus theta plus cos of 180 degrees minus theta times sec of 360 degrees minus theta all over 10 of 2 pi minus theta multiplied by cot of 180 degrees plus theta. All right, simplify. The question will say simplify. Now, I've indicated that angles can be given in radians or in degrees. So where we see pi, you must know the angle is in radians. So before you simplify, start by converting this to degrees. So pi to degrees, you multiply by 180 degrees over pi. Then it will give you 180 degrees. So it means where you see pi, it's 180 degrees. And then in the denominator here, we have 2 pi. This will also be multiplied by 180 degrees over pi, which will give you 360 degrees. Now, there are 2 ways which you can simplify this. You can use the calculator or you can use the cast rule. If you use your calculator, this is what you do as your first step. You press sine in your calculator and then insert 180 degrees plus 1 here. And then your calculator will give you a negative decimal number. You don't focus on that number, you only focus on the sign. So it means when you say sine 180 degrees plus 1, but you need to take note of something. When we have squared, it doesn't matter which quadrant is this. Your answer is going to be positive sine squared. But if the square was not there, we will have to insert 1 here and say sine of 180 plus 1. Then our answer will be negative 0, then that we ignore the number and then we would write negative sine theta. But because of a square, this one, whenever there's a square, it's going to be positive. So if you don't want to make mistake, better write everything as they are. Like write this sign. And then we do live with the sign whether negative or positive after. So we bring down sine squared. We bring down sine squared, theta. Then we also bring down plus cos theta. And then we bring down multiply by sec theta over 10 theta times, bring down this cot theta. Then once you have everything here on this step, we can now say, okay, let us see We are having sine squared. Whenever it's squared, it is going to be positive. You leave it like this. Then when you get to this one, you press your calculator. There's no square. Press cos in your calculator. Then insert 180 minus 1. So when you insert 180 minus 1, your calculator will give you negative and a decimal number. Ignore the decimal number. Just write here. This one is positive, sine, squared, theta. Then we have plus, negative, cos theta. The negative is from your calculator after pressing cos of 180 degrees minus 1. Times, we are having sec here, sec of 360. So, in your calculator, you don't have sec, but you know that sec is a reciprocal of cos. So, you will have to press cos and say cos of 360 minus 1. Here, you insert 1. Then the answer that you'll get will be a positive value. You don't take that value, you ignore the value, and then just consider the sign positive. So this will mean this sec will be positive sec theta over. Then this one, 10. 360 minus theta. In your calculator, you press 10. 360 minus, here, insert 1. So when you press 10, 360 minus 1, in your calculator, you will get a negative value. So you ignore the value, you just take the sign. So it will mean here, for this one, we will have negative 10 theta multiplied by, here we have cot. We don't have cot in our calculator, but we know that cot is a reciprocal with 10. So in your calculator, you will press 10, 180 plus 1. Then your calculator will give you a number that is positive. Ignore the number. Now write cot as positive. Positive cot theta. Now when you get to this step where you have sort out the signs, you have to remember the quotient identity, the square identities. You must remember the reciprocal identities. Sine squared, bring it down. In other words, in this step, it's where you express this problem in terms of sine and cos. When you are done with this step, you must only see sine and cos. Sine, bring it down. Positive times negative, cos here will be negative cos theta. Multiply. This is not cos, it's not sine. Then we have to make use of identity. The reciprocal here, sec is 1 over cos theta over negative, bring it down. For 10, 10 is equals to sine over cos. So you write sine theta over cos theta multiplied by. For cot, this is not sine, this is not cos. So cot is cos theta, that is from the identities. Cos theta over sine theta. Then you simplify. As you simplify, because there's multiplication between these two, cos into cos goes once, and there it goes once, meaning here we will have 1. In our numerator, we are having sine squared minus 1. And then as we simplify here, a negative multiplied by positive will be negative. Cos into cos goes once, there it goes once, sine into sine goes once, and then sine into sine here goes once. So in the denominator, our answer is 1. Let me write the answer for numerator and denominator. In the numerator, we have sine squared theta, sine squared theta minus 1. And then in the denominator, we have divided by negative 1 times 1, it's negative 1. Then as you continue, you go back to your square identity. We have this square identity, sine squared plus cos squared equals to 1. When you manipulate, sine squared will be equals to 1 minus cos squared. And then if we make cos squared subject of the formula, cos squared will be equals to 1 minus sine squared. So, You will make use of your identities and get to your final answer. Make use of your identities. So the most important thing here is to reduce, here reduction, so that you can find the correct signs. And then after that, express your problem in terms of cos and sine using the identities. Where you see tan, write sine over cos. Where you see cot, write cos over sine. Moving on, that is reduction. Now we move on to the functions. We are having three functions, the cos graph, the sine graph, and the tan graph. So learners, you need to remember the basic shape of your sine graph, cos graph, and the tan graph. In each graph, remember now, each one has got the range and the domain. You must also remember the period for each. The basic graph of a sine graph, here's the basic graph of your sine graph. If the maximum there is 2, and then here we have negative 2, when we identify period, amplitude, domain and range, your period for sine graph is 360 degrees. Your basic sine graph is 360 degrees. The period, remember, it should be for a complete wave. So your period for sine graph is 360 degrees. In this case, your amplitude, you see your graph is turning at 2 maximum and at negative 2. So your amplitude here is just 2. And then your domain, when you talk about domain, you need to look at your x-axis. It is from 0 degrees to 360 degrees. So your domain, you just say x an element of 0 degrees to 360 degrees. And then 0 degrees included as well as 360 degrees included. When you come to range will be on the y-axis. So your minimum turning point is negative 2. Your maximum is 2. That means your graph is from negative 2 to 2. So your range will be y an element of, you start with a small number, negative 2 to 2. And then negative 2 included as well as 2 also included. So you must remember, learners, that your range, you look at your y, your domain, you look at the x-axis where your graph starts and ends. Right. When it comes to sketching, suppose you are given f at x equals to 2 sine of x plus 30 degrees. You can use a table. You can use a table of which in the question paper this will be provided with intervals. But now, if you are confused, when we have x plus 30 degrees, this will guide you of the intervals that you can use the interval of 30 degrees. Meaning in your table, you will have 0 degrees, 30 degrees, 60 degrees, 90 degrees, 120 degrees, and so on. So when you use your calculator, you press 2 sine. In place of x, you will insert 0 degrees. Then your calculator will give you the corresponding value of 0 degrees. Other than the sine graph, we have the cos graph. Expect the cos graph as well. Here's the shape of your cos graph. So when you sketch the cos graph, suppose you have g at x equals to negative 3 cos theta. When this is negative, your cos graph will face down. But if it's positive, you will have this shape. Your cos graph has got also the range. So if it's turning here at -3 and there is 3, it means your range will be from -3 to 3. So if we are having our course graph from 0 degrees to 180 degrees, it means your domain will be from 0 degrees to 180 degrees. So functions sketching is very important because once you are grounded in sketching, you will be able to interpret your function. In trigonometry, we also have 2Ds and 3Ds. So when it comes to 2D and 3D, this is where you need to remember the sine rule, cosine rule, area rule. Suppose we have this A, B, C, and D. In this kind of question, this is whereby you will be asked to find the side or the angle. All you need to do is to identify the triangle, whether the triangle is a right angle triangle or a non-right angle triangle. If your triangle is a right angle, the side that you are looking for is in a right angle triangle. You have to calculate, suppose, BC. That is in the right angle triangle. This is what you are going to use. You use the trig ratios. You either use tan or cos or sine. So if we want to calculate BC, we identify the side given to us and choose between tan, cos, and sine. Our choice will depend on the information given to us and what we need to calculate. Meaning our choice must include what is given and what needs to be calculated. So in a right angle triangle, it's tan, cos, and sine, as well as the theorem of Pythagoras. Theorem of Pythagoras. So you must remember when you want the side in a right angle triangle, you make use of this 4. But if now the side that you need to calculate is in a non-right angle triangle, the side or the angle, this is where you will have to use either sine rule, cosine rule, or area rule. But this one, the area rule, you only use if in the question the word area is mentioned. When they mention the word area, whether they want you to calculate the area or whether they are giving you the area for you to calculate the side, you use area rule. Otherwise, the cosine rule will be used when two sides are given and an included angle. This cosine rule, you use it when we have two sides, this side given and that side, and an included angle. All right, moving on. Question 4, 5. Question 4, 5, 6. It's trigonometry. So we are moving on to question 7, 8, and 9. Euclidean geometry. 7, 8, and 9. In this question, learners, remember, it is very important for you to revise grade 8 and 9 geometry of straight line. And then your theorems of grade 11. You need to be able to apply them, and again you must know them, the wording, because there's always this question where you need to fill in the missing word. So when it comes to Euclidean geometry, straight line geometry of grade 8 and 9, and then the theorems of grade 11 are very important. Then under Euclidean geometry, we also have similarity and proportion. Similarity and proportion. This is the Euclidean that you learned in grade 12. That's where you will have a triangle with lines being parallel to each other. And then suppose this one is 3 and that one is 6. And then this one is unknown, A, B, C, D, E. And this one is 8. You must remember proportionality. If you want this side AB, you will say 3 over 6 is equals to AB over 8. And then you solve for AB. In Euclidean geometry, it is very important for you to write the statement as well as the reason. If you write that 3 over 6 is equals to AB over 8. Next to it, you need to write proportionality theorem. Now, when you get to question 10 is circles, angles, and angular movement. Now, learners, for question 10, your formula sheet must be nearby because all the formula are in the formula sheet. Let us now go through the formula sheet. Circles, angles, and angular movement, it's when you will be asked to find the length of an arc, the arc length, and for the arc length, learners, here is the formula to use. S is equals to r theta. S is equals to r theta. And then besides the arc length, under question 10, expect circumferential velocity. Circumferential velocity. For circumferential velocity, if you have to calculate circumferential velocity, the formula is also here on the formula sheet. We have the angular velocity. For circumferential, the formula is this one. V is equals to pi dn. Please ensure that when we work with this formula under question 10, your angle is in radians. So if the angle is given in degrees, convert it to radians and then substitute and then calculate. Now circumferential velocity, the formula is V equals to pi dn. Remember that, whereby n is rotational frequency and then your d is diameter. And then under question 10, angular velocity. For angular velocity to calculate it, the formula that you use is this one. It is on the formula sheet. Omega is equals to 2 pi n. So it means for angular velocity, the only thing that you are expected to substitute, it is your rotational frequency, which is n. Now in this one, you need to remember that if the rotational frequency is given in meters per second, you must divide by 60. If it is given in minutes in meters per second. So besides angular velocity, we have area of a sector. For area of a sector, the formula is also on the formula sheet. For area of a sector, your formula is RS over 2, whereby R is radius and S is the arc length. Then the other thing that you need to expect is calculating the length of a sector. This is the formula that we use, 4h squared minus 4dh plus x squared equals to 0. So basically for question 10, all the formula are on the formula sheet. Expect questions such as calculating the circumferential velocity of rotating blade. Calculate the perimeter of the belt. So for perimeter of the belt, your belt has got arcs. And some of the arcs are unknown. That will mean you will have to use the formula for length of an arc to calculate those arcs that are not given. Like this arc AF. You'll have to use this formula of S equals to R theta. When the angle is given in degrees, remember, it must be converted to radians before you substitute and calculate. Now, the last question. The last question is on measurement, mensuration. The question on mensuration, the formula are given on the question. So, each and every question that you'll be asked, there will be a formula for you to use. But please take note, when you use your formula and substitute, ensure that your units are the same. It is very important to ensure that the units are the same. I just wanted to show you how the last question, question 11, look like. Question on mensuration. Here is an example of question on mensuration. The formula will be given. And once you read the question, read it in such a way that you identify the correct formula to use. If it's surface area of a cylinder, in the formula it will be written. The formula for surface area of a cylinder is this one. So this question, you just have to read the question carefully so that you understand exactly what the question needs, and then choose the correct formula. And then make sure that your units are the same. Suppose here we have, instead of centimeter, we have meters. You will have to convert these meters to centimeters before you use your calculator and substitute here and use your calculator. Make sure that your units are the same. The other question on question 11 is of mid-ordinate rule. Mid-ordinate rule, you can either be given the length of equal parts, or you can have the whole length of this survey line. So you know when you have this distance from here to there, you will have to say 23 divided by 1, 2, 3, 4, 5, 6. Then the answer that we get will be the length of equal parts. Then for you to calculate the area of this irregular figure, there is a formula on the formula sheet that you will use. Here is the formula to be used. The formula that we use for the area of irregular figure is this one, whereby A is for equal parts. M1 is for mid-ordinate 1. So for mid-ordinate 1, let me just remind you, these are ordinates. You add the two ordinates and divide by 2 for you to get M1.